The incomplete information game depicted in graph 24.8 is a simultaneous incomplete information game because the two players play simultaneously. Despite the fact that we depict this game in a game tree where nature moves first, the two actual players are not moving in sequence, as indicated by the information sets that are drawn. We will now turn this simultaneous incomplete information game into a sequential incomplete information game, where player 2 moves first after receiving her type from nature. Such a game is referred to as a signaling game, because the player who is assigned a type by nature has a chance to signal her type to the other player who otherwise doesn't know what type she's playing against. As in any incomplete information game, we can model the player nature as moving first and assigning one type with probability rho and another type with probability 1 minus rho. The player we referred to as player 2 in graph 24.8 will now be called the sender, because it is the player who can choose to send a signal to the uninformed player. Once this sender has received her type from nature, she can choose to go left, or she can choose to go right. The player who was called player 1 in graph 24.8 will now be called the receiver. He doesn't know which type has been assigned to the sender, but he receives a signal from the sender in the form of the action that's taken by the sender, because unlike in graph 24.8, we're now assuming that the receiver takes his action after observing the action of the sender. But since both sender types can choose the action left, no information is necessarily revealed when the receiver observes the action left. Thus, upon observing left, the receiver ends at one information set that includes both the nodes in the tree as drawn so far. The receiver does, however, know his own payoffs from playing up and from playing down after left has been played by the sender, and since the receiver gets a higher payoff playing up when the sender has played left, he will end up playing up. If the receiver instead observes the sender playing the action right, he ends up in a different information set on the right side of the game tree. Once the receiver has observed the sender playing the action right, the receiver knows exactly what his payoffs will be from going up versus going down. Since the payoffs to him are greater from going down rather than going up, he will plan to go down after observing the action right from the sender. Finding the analogous to a subgame perfect equilibrium in this case is then particularly easy given the structure of the game. The sender knows that the receiver will go up if he observes a signal left, and down if he observes a signal right. A sender of type 1 will then know that if she goes left she'll get a payoff of 10, whereas if she goes right she'll only get a payoff of 5, and she should therefore go left. A sender of type 2 will similarly know that her payoff from going left will be 10, whereas her payoff from going right will be minus 5, and so she also should go left. The equivalent of a subgame perfect equilibrium strategy for the sender is then to play left regardless of which type she's been assigned. The receiver's subgame perfect strategy is to go up if he observes left and to go down if he observes right. The game is a special case of an incomplete information game in the sense that the beliefs on the part of the receiver don't matter. If the receiver sees a signal left, he unambiguously knows that he should go up regardless of which sender type has sent the signal left, and similarly, if he observes a signal right, he should go down regardless of what type has sent that signal. Beliefs will begin to matter in the next graph.